In this video, we'll show how to work with vectors, that is, how to perform basic operations on vectors. So here we have two vectors v and w defined using algebraic form, and in part A we have to find the linear combination of the two vectors. So first let's find 3v. To find 3v, we simply multiply each horizontal and vertical component by 3. So 3v is same as 9i minus 15j. Similarly, we can find 2w. 2w will be negative 4i plus 6j. And to subtract two vectors, we simply subtract them component by component. So 9 minus negative 4 I will be the horizontal component, and negative 15 minus 6 will be vertical component. So the final answer is 13i minus 21j. Now, to find the magnitude of a vector, we first have to have a vector written in algebraic form. So first let's find v plus w. V plus w will be simply 3 plus negative 2i plus negative 5 plus 3j. We again simply add the corresponding components. So 3 plus negative 2 is 1, and negative 5 plus 3 is negative 2j. And now to find the magnitude of this vector, we use the formula. So if we have vector v given to us in algebraic form, then the magnitude of this vector is simply a squared plus b squared, all that in the square root. So the magnitude of v plus w is 1 squared plus negative 2 squared with the square root, so it's square root of 5. In part C, we ask to find the magnitude of v and magnitude of w separately. So magnitude of v will then be square root of 3 squared plus negative 5 squared, which is square root of 34, and magnitude of w will be negative 2 squared plus 3 squared inside of the square root, and the sum of the magnitudes is simply square root of 34 plus square root of 13. Notice how the sum of the magnitudes is not the same as the magnitude of the sum. That's a common fact. In part D, we ask to find the dot product of two vectors, and to find the dot product of two vectors given algebraically, we simply multiply their corresponding components and add them together. So in this case, the dot product will be equal to 3 times negative 2 plus negative 5 times 3. So the answer is negative 21. So these are the examples of some basic operations on vectors.